Our first speaker will be Jim Burke, who is the virtual reality program that the Mars Society has launched and which we hope to expand significantly, along with Shannon Norell, who's here somewhere. Okay, hiding behind Jim Burke. Leading the development of our virtual reality program. Okay, so Jim.
So good evening, everybody. Happy 20th anniversary to the Mars Society. I'm a founding member. So this year we started the Mars VR program, which we see as a multi-phase effort to introduce virtual reality to our public outreach activities and to our projects like the Mars Desert Research Station. And we had a successful Kickstarter in May. Our goal was to raise $25,000, and we raised $31,000. And with that money, we were able to hire some folks to professionally fly drones and scan the Mars Desert Research Station in Utah using the latest photogrammetry techniques. So one of the folks that we have on our team is probably one of the best in the world to do photogrammetry. And we've done several now iterations of scanning the terrain around the MDRS with drones. We've gotten a square mile of terrain. And so I'm going to show you our terrain model. And so this is a pretty low resolution version of what we have. What we did was we flew the drone first at 200 feet. Our goal was to get fist-sized rocks visible in the VR environment. Because what I would really like to see happen is I would like a geology person to put on a VR headset before they come out to the MDRS and plan out their EVA and plan out what they want to see when they actually get there.
So there's the MDRS itself.
Yep, there's the MDRS right there. So we first flew it at 200 feet, and our expert, Ben Stogan at AeroScout in Grand Junction, Colorado, he has a company that does a lot of work for the mining industry, flies drones. He thought, well, we could do that with a 200 feet pass. So that's what we did at first in June. But then we got the results back, and we're like, no, this isn't good enough. We need to do it again. We need to fly at, what are we doing now, 50 feet? 50 feet. So he's actually today doing the last one of those. He's out there today. We've taken 20,000 or so DSLR photos. We rented a LiDAR system, which is like a laser radar system. We rented that. We scanned the inside of the MDRS, and we'll show you that in a second. Do you want to mention anything else about the terrain?
Well, just kind of to put this in context, this is arguably one of the largest and most detailed models ever created using the photogrammetry and techniques that we're employing here. So yeah, I'm glad you brought up the point that we actually scanned a square mile, which took 3 days, and then we said it wasn't good enough, and we went out and scanned it again. So you know, the objective of this entire mission is to use VR as an actual scientific tool to actually do science with it, and it's not just going to be a fun toy, a fun experience. So I mean, it'll be fun, but it should be realistic to the extent possible. So the goal is, like you said, to have at least softball-sized rocks visible from all angles. And there are certain parts where they're going to be occluded. You can see there's like some cliffs and things like that where you're not going to probably see underneath the rock. So we may come back in and touch that up with actual DSLR photos and stuff like that. So it's going to be a work in progress. It's going to evolve, but hopefully we can exemplify how to do real science with VR. So, you know, hopefully we can send people to, or send drones or robots to Mars itself and come up with scans of large expanses of land and then direct actual humans to go explore them in greater detail. And we can all sort of look over their shoulder in VR and direct them to interesting parts. We can kind of, this was Robert Zubrin's idea last year at this conference, as far as like letting people virtually explore the terrain and find interesting objects and point them out as objectives in meat space, so to speak. So that's what I had to say, I guess.
Yep.
Let's do
So,
some demos.
yeah, absolutely. So one other thing I'll say is this is phase one. Our goal for phase one is MDRS. We want to make sure that we build a crew training simulation that the crews can use at home before they go out to the MDRS so they can hit the ground running, because every moment at MDRS is precious, just like being in space, and we want them to make the most of it. So we're going to show you now our demo environment. So I'm going to open up.
Does not include the terrain, it's just the
Yeah, so this is a very early build of what we're going to do. We're planning on releasing all of this in October before the field season starts. And we will have this available to the public for free. It'll be open sourced. And we will provide a key to unlock the training content for people that pay a $30 fee on the Steam platform. But the general public will be able to make use of this for free. And we really hope that this is a great educational tool for museums and schools. We want to get the word out about what we're doing at the MDRS. So this is our demo environment, as you can see.
Yeah, I wanted to give you a sense of scale. You can see that this is the actual terrain that was scanned, that we're still processing and stuff like that. But here's the MDRS over there. So
Yep, right here.
it's a large expanse of land. And this is just the beginning. We could add other sections if we just have more time. So what do you want to do?
So just go through the rooms one by one, start at the airlock. So this is actually my favorite room, even though it's the smallest one, because the detail. You can say, and one person said, I'm so glad this is like a realistic looking thing, it's not a science fiction thing. You can look at the cracks on the donor plaque, for example. That's how good this scan is.
Yeah, it's really like you're here.
Yeah. So the way the environment works right now is this is just a demo. So we're eventually going to tie all the rooms together as they should be, but for the demo purposes today, we wanted to just have this lobby to show them all.
So I guess we go to the EVA prep room.
Let's do the EVA prep room, yeah. So this is where all the crew members at MDRS start suiting up and putting on their simulated spacesuits.
There's the other side of the airlock.
That's the other side of the airlock. Go a little slower, Shannon. I know you're excited. So as you can see, this scan is a 3D scan. You can look around these objects and see all of their edges. As a matter of fact, in some of the other rooms, you can actually look under the table and look at the bottom of the table. VR people that have seen this stuff are saying that this is like one of the best apps they've ever seen done in VR.
So the idea is that you have this mission thing here. Can you guys see this? Yep. So it was a step-by-step guide, and you know it gives you an indication of what to do in order. So put on flight suit, including boots. So down here would be where we still have to flesh all this out. But down here we can grab the flight suit, we put it on, then that step is like complete. So and then we gotta go put on the backpack. So we gotta go find the backpack over here. And I put it on, and now it's checked off, right?
Yep,
There we
it's
go.
checked off.
So then, et cetera, et cetera. So there'll be various missions that are built in here that you follow along until you practice doing a mission before you get to the actual MDRS.
And we're working with Dr. Rupert to flesh out exactly what those scenarios and procedures should be so that they're extremely accurate as to what the crew members actually do. Science Dome. Now, bear in mind, we scanned the MDRS at the end of the last field season, so it is sort of in a bare state right now, which we wanted to do on purpose because what we can do now is we can add in 3D objects that we create to do some of the procedures. So for example, with putting on the suit, we will have a scan of the suit, and it will be an object you can actually manipulate in the environment. We're using an HTC Vive off-the-shelf headset, and one of the features of that allows you to teleport around in the room. Whoops, something happened there, Shannon.
Oh, you can't see me?
No, we can see you now. It's good now.
Can everybody hear Shannon? No, all right.
Oh, let's, yeah. Thank you.
By the way, Shannon, there was a great thing going bing in this room, bing, when we were there. I never could figure out what it was. Okay. Anyway, no, everything was shut down for us to do the scan, so.
Oh, you know what it was? It was actually, there was a CO monitor that was needed a new battery.
Okay, okay. So yeah, you can see there's a certain amount of artifacts in here that need to come in. We need to come in and scrub up. For instance, glass does not really scan that well with photogrammetry. So we'll probably scoop these things off and, clean out the models and put actual 3D models in here that you can interact with. So it's, like he said, it's a work in progress as far as, first round of scans. But it gives you an idea of the level of detail we have. I mean, I can see the rebar handle here, really detailed. Okay, what's next?
Let's do the green hab.
Oh, green hab.
It looks kind of messy, just as a caveat here. There's some dead plants, unfortunately. That's how it was when we got out there, but we're going to clean this up. We're going to digitally remove some of the junk. We're going to add in real plants that will be part of the training procedure. And we'll work with Dr. Rupert, and she can't even look. We'll work with Dr. Rupert to really make this accurate as to what we want to have people train on.
I have to tell you guys that we were here in June, late June, early July. It was the hottest place I've ever been in my entire life, was in this green hab. Because it's designed to keep, the heat in, right? And, oh my God, it had to be 140 degrees.
Yeah, I think pretty much everybody that we sent out there got heat stroke.
Yeah, we all died. Okay.
You will be able to, not in this build.
Yeah, it'll be completely connected as there. Sure. Yep.
Absolutely. We
Yeah,
scanned
you could
everything.
show the Matterport scan.
Yeah, I'll do that.
Sorry.
Let's do the Matterport after we're done with this.
So next is maybe Musk Observatory.
Yes.
Okay,
So it's a little dark in here, but this is the Musk Observatory. This is
Yeah.
a small observatory that we built with funds donated by the Elon Musk Foundation. This was our first observatory at the MDRS. We now have a second one that's fully robotic that can be controlled over the internet. And so this first one has now been converted to a solar observatory.
I hope you guys could see the detail of the telescope itself. It's pretty cool. It's pretty vivid.
What we'd like to do with the training in here is once the person learns the astronomy procedures that Peter Detterlein and his team have, then they'll get to open the dome as a reward.
Okay.
And then the RAM.
RAM.
Yeah. So this is our repair and augmentation module, and Shannon's hiding her eyes again over there because there's a lot of junk in here, according to her. This is actually a Chinook helicopter that has been retrofitted. My favorite feature of this is the Phoenix rover that the NorCal chapter built. There it is.
Oh, look at him right there.
I know you guys want it back too. But yeah, you can actually, you can look under the tables here. You want to try that, Shannon?
Oh, yeah, sure.
Like, look at that. It's awesome. Look at that note taped to the table.
Oh, there's my toothbrush.
There's his toothbrush.
Yeah, I was looking for that. So yeah, the idea is to articulate, so you'll be able to pick up the hammer and smack on stuff, you know, to sort of animate or make these things interactable to the extent they apply to mission.
So one of the things we may do in the future is have a suit repair training scenario in here.
That's
I
all
think
the
that was
rooms we
everything,
have
yeah.
done, yeah.
So what do you guys think so far? Pretty good, huh?
Cool. Oh, thanks for doing that.
So one of the other things we were able to do while the team was out there, we borrowed a camera from a company called Matterport. And we've actually had a lot of success just talking to some of these VR companies about this project. They're very supportive. They're very excited about it. We're able to do some co-marketing with them. We're just kind of getting started with some of that. The company that we're using, their software to process all this terrain is called Pix4D. And when I talked to the representatives there, they were so excited about this project. They sent me an email that said Pix4D is going to Mars, and they featured us in their blog. They gave us a donation of a $10,000 software license for a year, and we've been using that to. So next, I'm going to pull up the Matterport scans.
By the way, James is really awesome at asking for help from companies and getting it, like every time.
So this is the Matterport. This is basically the upper deck of the HAB. Now this is a 360 camera that you basically set down, you push a button, and it does a 360 scan of the room. It's used a lot in the real estate industry. So a lot of real estate agents will rent one of these and scan their property, and it'll be on their website. But what we did is we took, I don't know, a couple dozen scans did you do of this? Or maybe 20, something like that?
Yeah, probably 40 in the
40.
Yeah.
So wherever you see a white circle on the floor is where he did a scan, and you can actually go around the whole MDRS this way. You can even go in the staterooms this way.
Yeah. It's 4-star in there.
Yeah, 4-star accommodations. Yeah, nothing but the best for our crews. I think it crashed or something. I don't know. So we actually have scanned all the buildings with Matterports as well. We have the Science Dome and the RAM and everything else too.
Yeah, they did all the connecting portals from one to the other too, so we can get that going.
So let me do this again.
Yeah, warts and all. Warts and all.
What is it doing? But I believe you know some folks at Matterport, and they may be using this in some of their marketing.
Yeah, well, I know Matt Bell, the founder of Matterport. He's the Matt of Matterport.
So you know the founder of Matterport.
of
That's
course.
great. So here's the main room of the lower deck of the HAB. We don't have that in the VR demo yet, but we've captured all this as well. There's the airlock.
You can go in the equipment room too,
Yeah.
right there.
Yep. There's the prep room that we were showing you before. So this has been available. This is out on the web. Anyone can take a look at this. So I'm sorry? Yes, we will send the link.
I think you just go Matterport MDRS, and there it
yeah.
is, I think.
It's also, we have a website called marsvr.io where we link to all this stuff. Let me just show you that briefly. We've been featured in the Red Bull blog. We've had a story written about us on space.com, Spaceflight Insider, Mars Daily, just a lot of stuff going on. There was even a Colorado local TV affiliate that did a local news segment featuring our rover, or our drone flying team. So. Anything else? Yeah, any questions? Go ahead, Nicole.
One, can you use the cell phone version?
Yes, that's a great question. So this phase 1 environment, we're estimating the amount of terrain that we've scanned currently, the 1 square mile. It's going to be about 150 gigs of data that people are going to have to download. So the answer to your question is no. You can look at the Matterport scans with your phone. We'll do stuff like that after we're done with this. There's a device called the Oculus Go that's really popular. It's a $200 wireless headset. It's perfect for education. I'd love to do something for that. So we're. That's also something we really want to do multi-user in the same environment. That would allow a lot of scenarios where people can explore together, but that's not in the first version.
Do we still have that fellow's credit card?
Go ahead. It's actually, we're going to put it up on Steam, and most games these days are around that size, so it's not that big. Question.
So can you overlay other layers of data? You know, like if you had mineralogical data or other kinds of data layers, could you?
Yeah, so yes, this is going to be open sourced and available to other developers to use. We're going to put it up on GitHub, including our Unity project. So someone could download the Unity environment, download our project, and work on it. And we're going to show them how to do that. So yes, you could overlay things. We'd love to see someone make a game layer for this, for example. You know, that's something someone could do. But yeah, we're going to be open sourcing. What we really hope is to build a community that uses this, that gets the word out about MDRS.
This is the last question.
Okay.
Prompted by your earlier comment about meat space, which I refer, I suppose, to the human world. Right. Now, is Mars ever going to be part of meat space, or is the singularity going to overtake it and render the whole thing moot?
Well,
in your opinion.
We're already in a simulation anyway, so. Yeah.
Beware of the meat, especially with mustard.
All right.
Thank you all. Thanks a lot.
We just got the hook.
And let me just say here that the ultimate vision here is showing NASA the power of VR, showing the public the power of VR. So the idea is that a human Mars mission would create a VR landscape so that millions of people on Earth can explore alongside the astronauts on Mars. It means a radical democratization of the exploration process. It means that when people go to Mars, when we won't just be sending 4 or 5 or 6 astronauts, we will be sending millions of us will be able to go along with them and tell them what to do.